So, welcome everyone to today's webinar, What is Foodborne Illness? This is the first webinar in this series, Food Safety Foundations. I'm Danielle Pereno, and I'm the program coordinator for the food systems team. I'll be the facilitator for today's webinar. Also with us is Rick Meyer, who is here to assist with any technical difficulties. You can direct message Rick in the Zoom chat if you are experiencing any problems. He will also be sharing links that we discuss and any information in the chat, which is on the side of your screen, throughout the webinar. And our speaker today is Amy Johnston. Amy is a regional extension educator on the food systems team working in the area of food safety. She earned a Bachelor of Science degree in dietetics from Michigan State University and a Master of Science degree in public health nutrition from Case Western Reserve University. Amy is a certified food protection manager, certified HACCP and GMP for food processors and manufacturers, and has completed other specialized food safety trainings.
Thank you, Danielle, for getting us started in the introduction, and thank you, Rick, for supporting us today. The topics we'll be covering today include defining foodborne illness and the symptoms a person may experience, explaining the types of hazards that can contaminate foods and beverages and lead to illness. We'll provide an overview of foodborne outbreaks in Minnesota over the last 12 years, and we'll go into detail on 9 illness-causing bacteria or viruses, and then lastly, talk about how and when foods and beverages can become contaminated. So whether you're joining us to benefit your food business or you just want to learn more, I hope you leave this webinar with increased confidence in your ability to prevent foodborne illness. So at the end of this webinar, you'll have new or increased knowledge about the hazards that can contaminate foods and beverages, know how and why to report symptoms of foodborne illness in the unfortunate event of eating a contaminated food. And lastly, be able to identify illness-causing bacteria. My hope is then that you apply this knowledge to your own food business or your personal life to minimize risks. So let's dive in. I'm curious, what do you think of when you hear the phrase foodborne illness? Okay, so thank you all for sharing your thoughts and giving the whiteboard a try. There is definitely some of these ideas that you see on the screen. You guys came up with food poisoning, sickness, stomach flu. So what is foodborne illness? So the official definition of foodborne illness, pretty simple. When a person gets sick from eating foods or beverages that contain harmful contaminants. Again, yeah, pretty straightforward, but what are those harmful contaminants? So there's 3 types of harmful contaminants or hazards that can make food and beverages unsafe to eat and cause injury or illness. And these hazards are physical. So a physical hazard is any fragment or material that's not expected to be present in the food. So physical hazards can include fasteners from boxes or bags, wood splinters from crates, food pits or stems that should have been removed during processing, broken glass, metal or plastic shards from equipment, pests and droppings. A physical hazard's more likely going to cause an injury to the person who accidentally ate it rather than a foodborne illness. So those kind of injuries may include dental damage, a cut in the mouth, throat or intestine, or choking. The next hazard is chemical hazards. So a chemical hazard is any substance in or on a food that may cause injury or illness when consumed. So these hazards may include things called mycotoxins, and those are toxins produced by certain fungi or molds, agricultural chemicals that were used inappropriately. So if too much fertilizers or pesticides are applied, industrial chemicals like cleaning solutions or sanitizers, heavy metals, and even unapproved or unsafe use of food additives and color additives if they're not labeled or used properly. And then undeclared or mislabeled food allergens and ingredients on product labels can also be a chemical hazard. So a chemical hazard can cause illness or injury, many times nausea, gastrointestinal distress, could damage the mouth or the esophagus, or sometimes more severe. And then the last hazard is biological. A biological hazard is any microorganism that can cause illness when consumed. Biological hazards are a frequent cause of foodborne illness and outbreaks. They include pathogens or illness-causing bacteria, viruses, parasites, molds, yeasts, and fungi. And the illness-causing bacteria and viruses we'll be discussing later in this webinar are examples of biological hazards. And these hazards all contaminate foods and beverages when unsafe food handling practices are used. Symptoms of foodborne illness can start very quickly after eating a contaminated food or beverage, but sometimes symptoms might not start for up to 6 weeks after eating the contaminated food or beverage. And this can make identifying the cause of the foodborne illness very challenging. I mean, I don't know about you, but sometimes I can't remember what I ate 2 days ago, let alone a couple weeks ago. The symptoms can include nausea or upset stomach, vomiting, and diarrhea. Those are the most common. But other symptoms can include fever, headache, body aches, or feeling tired. This too makes identifying foodborne illness challenging because these symptoms could be mistaken for another illness. And when we're looking at these symptoms, it's clear that a person's GI or gastrointestinal tract is the main part of the body targeted or impacted by these illness-causing bacteria. However, certain bacteria can cause vision problems, such as difficulty seeing or blurriness. So if you or someone in your household or someone at work is experiencing any of these symptoms, it's best to see a doctor and report it if foodborne illness is the suspected cause. So again, if you think that you have foodborne illness, report it and your symptoms to the Minnesota Department of Health, Minnesota Foodborne and Waterborne Illness Hotline. An investigator will ask about your symptoms, including when they started, the types of foods you've eaten, and other details to help them identify the cause. Rick is going to share in the chat links to the Minnesota Department of Health website, so you can bookmark it for future use if you want. And it's important to report your symptoms because depending on the source or the cause, you can help prevent other people from getting sick, and also help get contaminated food off the market. So how are we doing in Minnesota as food business owners, entrepreneurs, growers, or just residents of Minnesota? It's important to be aware of the bacteria that cause foodborne illness outbreaks. Foodborne illness is classified as an outbreak when 2 or more people who ate the same food from the same place or source in a similar time frame and are having similar symptoms. So in Minnesota, the Department of Health investigates the reports of foodborne illness and will determine if it's an isolated incident or an outbreak. So on the screen, you can see some data from Minnesota Department of Health through the years 2010 through 2022. And this shows that in Minnesota, there were 640 outbreaks. That's what that N equals, 640. So we had 640 outbreaks. 50% of those outbreaks were caused by norovirus, 20% from salmonella, 6% from STEC, which is Shiga toxin producing E. coli, and 4% from Campylobacter. The remaining 9% from bacterial intoxications are from a variety of pathogens that produce a toxin, and then that toxin makes people sick, and 11% from other or unknown sources. And we will talk more about these pathogens here shortly. And then the last report from the Centers for Disease Control and Prevention, or the CDC, on the surveillance of foodborne disease outbreaks in the United States is from 2017. And in that report, Minnesota was ranked 10th for the number of foodborne illness outbreaks. So that means only 9 other states reported more foodborne illness outbreaks than Minnesota. So I personally think we have a little bit of work to do. And that work starts with understanding the biological hazards or pathogens that can make us sick. According to the CDC, there's 31 pathogens known to cause foodborne illness. We're only going to go into detail on 9 of these pathogens today. And then just a quick note as to why some of the pathogens are written in italics, such as salmonella. This is just due to the scientific nomenclature or the naming of these microorganisms. When we're talking about a specific species of a pathogen, it gets italicized. So STEC is not italicized because we're not talking about just one specific kind of E. coli. And just a reminder, pathogens are illness-causing bacteria, which are biological hazards. So you may see or hear those terms used interchangeably. Okay, so norovirus. So first up is norovirus. And as we saw on the previous slide, norovirus is the leading cause of foodborne illness in Minnesota. It is frequently called the stomach flu, which can be misleading because norovirus attacks a person's gastrointestinal or GI system and not the respiratory system or the lungs, which is where the influenza or the flu virus attacks. Outbreaks of norovirus are frequently seen in settings where people are in close contact or proximity. So again, think of those winter months, we see spikes, but also childcare centers, senior living facilities. I think every year there's at least one cruise ship that reports a norovirus outbreak. And this is because the virus can spread really quickly and easily. The symptoms include what we've previously discussed. So going forward, I'm not going to spend much time on the symptoms unless there's a unique or a different one. A person can begin experiencing symptoms relatively quickly after eating or drinking contaminated food, and symptoms usually last for 3 days. However, someone who was infected with norovirus may be able to spread it for up to 2 weeks, even after their own symptoms have stopped. Norovirus can contaminate foods in two different ways. First is if a water source becomes contaminated, and then that water is used for drinking, growing, or washing raw produce. Also, if the water where shellfish live is contaminated and that shellfish is harvested and then eaten raw, the virus can make people sick. The second, which is the most common way that norovirus spreads, is through the handling of raw or prepared foods by somebody who is infected with norovirus. The contamination can occur during harvesting, packaging, preparing, cooking, serving, and even selling the food. So it's important to note that norovirus does not need these food sources to grow or multiply because it can live on surfaces. Norovirus is associated with these foods because through contamination or unsafe food handling practices, these foods can carry or act as a vehicle for the virus. And once a person eats the food, they can become sick. So to destroy or kill the virus on hard surfaces like counters or equipment, use an appropriate sanitizer solution and disinfectant. If these surfaces are food contact surfaces, check the instructions and make sure it is safe for food contact surfaces. There are a variety of chlorine or quaternary ammonium solutions available. Our March webinar of this part of this series will include a focus on sanitizing solutions. So whatever you're using, follow the instructions, paying close attention to the amount of time needed to have contact with the surface, and if it needs to be rinsed or let air dry. Cook shellfish to a minimum internal temperature of 145 degrees Fahrenheit. Norovirus is resistant to heat, so just a quick steaming may not be sufficient in killing the virus. So if you choose to eat raw shellfish, purchase from a reputable supplier or restaurant and just be mindful of food recalls. And cooking raw or frozen produce to a minimum internal temperature of 145 degrees Fahrenheit before eating or using as an ingredient in a food product can increase food safety. As norovirus can spread easily and destroying it requires the use of a sanitizer or thoroughly cooking foods, preventing the spread is extremely important. When growing and processing produce, use approved water sources. Frequent hand washing, especially after using the toilet or cleaning up after somebody who is sick, are key to stopping the spread of the virus. And hand sanitizer may be insufficient in killing the virus, so it should only be used with proper hand washing. And then again, as this virus can live on surfaces and prepared foods, do not handle food if you are sick or someone in your household is sick. Wait at least 3 days after the symptoms have stopped before returning to work or handling food. And remember, handling of food includes handling packaged food items for sale. And again, as the virus can live on surfaces for extended periods of time, it's so important to have a routine cleaning and sanitation procedure, especially with an emphasis on those high touch or high traffic points like handles and on doors, refrigerators, and drawer knobs. And always wash fresh produce before preparing or eating it. Produce should be thoroughly washed, even if it's going to be cooked. Like norovirus, hepatitis A is a virus that is not naturally found in the environment or certain foods, but contaminates food through contaminated water or unsafe food handling practices. The virus does not grow or multiply on these foods, but again, the food acts as that vehicle to move the virus. And after somebody eats a contaminated food, they may become sick. The hepatitis A virus attacks a person's liver and causes symptoms like dark urine and jaundice, which is yellowing of the skin and or eyes. There is testing and a vaccine available to prevent hepatitis A infection. So if you're interested in learning more, Rick will share links in the chat to a fact sheet by the Minnesota Department of Health. The hepatitis A virus can be destroyed or killed by cooking foods to 185 degrees Fahrenheit for at least 1 minute. That's a very high temperature, which can result in an undesirable texture of the food. So sourcing foods from reputable suppliers and using safe food handling practices to prevent the spread are critical. It's essential that if you or someone in your household is sick, that you do not return to work or handling of food until cleared by a doctor. And again, the handling of food includes harvesting, processing, preparing, selling, or serving. Next up is salmonella. According to the Minnesota Department of Health, there are between 700 and 925 individual cases of foodborne illness caused by salmonella each year. There's different strains of salmonella that are associated with different foods, but the symptoms are similar. Many people are aware that raw or undercooked poultry and eggs can be a source of salmonella. The salmonella bacteria is naturally present in the GI system of many animals and birds. It does not make them sick, but the eggs and meat can become contaminated with the salmonella bacteria during the laying of eggs and the butchering of the animal if there is contact with feces or contents from inside the intestine. Unpasteurized or raw milk and products made from that milk have also been linked to salmonella outbreaks. Pasteurization is the process of heating foods or fluids to a specific temperature for a specific amount of time to sterilize that food, and then rapidly cooling to prevent any new bacteria growth. Oops. Sorry, I forgot to advance. Produce has also been linked to salmonella outbreaks as a result of cross-contamination, which is the spread of bacteria to a non-contaminated food. The produce can become contaminated during growing or processing. If a contaminated water source is used, and unpasteurized juice can also be a source of the bacteria if that produce had been contaminated. Our February webinar will go into detail about what bacteria or pathogens need to grow. Produce can also be contaminated during production or cooking if the same equipment or utensils used to prepare raw meat and poultry are used to prepare produce, or if meats or poultry juice drippings landed onto produce in storage. And then just a random side note, reptiles, whether in nature or as a household pet, have also been linked to salmonella, so proper handling and hand washing is important. Salmonella can be destroyed by thoroughly cooking foods and pasteurization. Cook eggs to 160 degrees Fahrenheit and poultry to 165 degrees Fahrenheit. If preparing runny eggs, use pasteurized eggs. Pasteurizing milk and using that milk to make cheese and other dairy products also reduces the risk of the hazard. Properly cleaning and sanitizing equipment, utensils, and surfaces before and after handling raw eggs, poultry, and meat will prevent any spills from causing contamination on other foods. To minimize the risk of foodborne illness or the spread of the bacteria, use many of the same strategies we've already discussed. Additionally, prevent that cross-contamination by using separate clean utensils and equipment when preparing or processing foods. If you're preparing foods that contain eggs but do not require cooking, use pasteurized eggs. So this would include things like hollandaise sauce, Caesar dressings, some homemade ice creams, mayonnaise, and even some frostings. Next up is Campylobacter. Campylobacter is the #1 cause of foodborne illness-related diarrhea. And this may be because it takes just a very small amount of the bacteria to make somebody sick. In fact, just a single drop of raw poultry juice, if it contains the bacteria, that single drop will have enough to make somebody sick. So similar to Salmonella, Campylobacter is naturally present in the GI system of animals and birds. And again, while it does not make the animals and birds sick, it can make people sick. So handling or eating undercooked or raw poultry is a frequent cause of illness. Raw milk can be contaminated with the bacteria, and then any dairy products made from that raw milk. And then water can also be contaminated if there are animal feces that run off into that water. So Campylobacter can be destroyed or killed by thoroughly cooking poultry to 165 degrees Fahrenheit and pasteurizing milk. Properly cleaning and sanitizing equipment and utensils and surfaces before and after handling raw poultry and meat can prevent contamination from any spills that may have occurred. So you're probably noticing a lot of similarities in how we can prevent the spread of bacteria as we talk about each microorganism. Frequent hand washing when handling live poultry, harvesting eggs, butchering and processing poultry, preparing or cooking poultry is very effective in preventing the spread. Those who raise their own backyard flocks need to practice the same diligence to hand washing as small and large scale farmers do. And then preventing cross-contamination when preparing foods by using separate utensils and cutting boards is very effective. There are over 700 different types of E. coli, but only a handful can actually cause illness in people. Our guts or our GI systems contain bacteria. Some of these bacteria are good and others are harmless. STEC is that Shiga toxin producing E. coli, and that's a type that can cause foodborne illness. The toxin produced by this type of E. coli can severely damage the lining of a person's intestines and kidneys. There have been many large-scale and multi-state outbreaks caused by STEC that have resulted in the deaths of both children and adults. Just to name a couple, in the late 1992 to early 1993, there was the outbreak related to the undercooked hamburger patties served at the Jack in the Box restaurant chain out on the West Coast. In 1999, the water source at a county fair in New York became contaminated and sickened many people. So in 1994, the Food Safety and Inspection Service declared this type of STEC, E. coli 0157H7, as an adulterant in ground beef. So what that means to be an adulterant is that there's a zero tolerance for the presence of the bacteria on the ground beef sold in the United States. So if it is detected, all of that product must be recalled. So beef can be a source of this type of E. coli because it is present in the GI tract of cows. Similar to the previous pathogens, raw or unpasteurized milk and any dairy products made from this milk may contain that bacteria. Water can become contaminated from animal feces, and when that water is used, or when that water is consumed or used to irrigate crops, contamination can occur. So this is how leafy greens have become a source of past E. coli outbreaks. There's been contaminated water used to irrigate those crops. So E. coli is destroyed or killed at the temperature of 160 degrees Fahrenheit. Ground beef and foods containing ground beef should be cooked to a minimum internal temperature of 160 degrees Fahrenheit. Whole cuts of ground beef should be cooked to at least 145 degrees Fahrenheit. And the difference between these cooking temperatures is because of the processing of the beef. So when ground beef is made, there's meat from multiple cows, from whole cuts that all get ground up and mixed together. If meat from just one of those cows became contaminated during butchering, that bacteria is now mixed up throughout the entire product batch. However, if a whole cut of beef is accidentally contaminated during butchering and it's left whole, that bacteria is going to stay on the surface of the meat. So the cooking temperatures are recommended for that internal or that center of the food. So when you're cooking a whole cut of beef, so like a steak, the outside is going to be heated up faster and for a lot longer than the middle of that whole cut. So when the middle of the whole cut reaches that 145, the outside is going to be at a much higher temperature already. But for the ground beef patties or foods containing that ground beef, because it is mixed up, that minimum internal temperature needs to reach 160 degrees because the bacteria could be spread throughout that entire food. Pasteurizing milk and juice made from raw fruits and vegetables will also destroy the bacteria. When preparing raw produce, it's very important to thoroughly wash it before preparing and eating and protect it from contamination by storing it above or away from raw animal products. Okay. While foodborne illness from Listeria monocytogenes is less common compared to other bacteria, its symptoms can be very severe in pregnant women, newborns, older adults, and those with weakened immune systems. In Minnesota, there's only between 4 and 19 cases of foodborne illness from Listeria monocytogenes reported each year. The symptoms that make this illness so severe are when a person's nervous system are impacted. A person can experience headache, stiff neck, confusion, loss of balance, or convulsions. Identifying Listeria monocytogenes as the cause of foodborne illness can be challenging because the symptoms may not appear for 2 to 6 weeks after eating the contaminated food. Unpasteurized or raw milk and dairy products and cheeses made from this milk can be a source of the bacteria, as that bacteria is naturally present in the GI system of cows. The Listeria monocytogenes bacteria is also just naturally present in the soil and environment. Ready-to-eat foods or RTE foods can become contaminated during processing if proper hand washing and food handling procedures aren't followed. And what makes Listeria monocytogenes different from other microorganisms we've discussed so far is that it can grow in packages where there is limited or no oxygen. So foods like deli meats, hot dogs, cheeses that are packaged in these tightly sealed packages that have oxygen removed have been associated with outbreaks. So ROP, or reduced oxygen packaging foods, have special processing requirements outlined in the food code to minimize the risk of bacteria growth. And again, the February webinar will go into detail about what bacteria need to grow. The Listeria monocytogenes bacteria can be destroyed or killed by cooking foods to 165 degrees Fahrenheit. Those at risk for experiencing the severe symptoms should either avoid the ready-to-eat or reduce the oxygen packaged foods that have been linked to the illness, or cook those foods to at least 165 degrees Fahrenheit. And the Listeria monocytogenes bacteria can grow in cold refrigerator temperatures. So following the sell-by and use-by dates on associated foods like deli meats, is extremely important because these dates are based on the rate at which, if bacteria were to be present, how quickly it would grow to a number that could cause somebody to become ill if they ate it. Okay, the Clostridium botulinum bacteria produces spores under the right conditions. And it's these spores that produce a toxin that's poisonous to humans and causes the illness botulism. The symptoms of botulism are very serious if untreated. A person may experience vision problems, such as blurred vision or difficulty seeing, have trouble swallowing, and respiratory failure. Cases of botulism are very, very rare across the United States, with only about 110 cases reported each year. And thankfully, because of increased awareness and treatments, the death rate has dropped from 50, so 50, down to 8%. The Clostridium botulinum bacteria is naturally present in the soil and environment, and similar to the Listeria monocytogenes bacteria, the Clostridium botulinum bacteria can grow and produce spores in packaged foods that contain little or no oxygen. So certain low acid foods like vegetables, meats, poultry, fish, when they're canned, they need to be pressure canned, which involves processing at a very high temperature for a specific period of time. The temperature range reached during pressure canning is between 240 and 250 degrees Fahrenheit. And that temperature is high enough to destroy any spores that were formed by the bacteria. Destroying the spores is really essential because that prevents the toxin from being produced, because it's the toxin that causes illness. Reduced oxygen packaged foods, that ROP, have, again, special processing requirements to help prevent spore production and toxin production. The toxin produced by the spores is heat sensitive, so it is recommended to boil home processed, home canned, low acid foods for 10 minutes before eating. So again, that's those low acid vegetables, meats, poultry, fish that were pressure canned. And using safe food handling practices such as hand washing, washing produce, and preventing cross-contamination are all important to follow when preparing foods that will be pressure canned or packaged in using a reduced oxygen packaging method. Clostridium perfringens. Many people don't recognize that pathogen name, but Clostridium perfringens is one of the most common causes of foodborne illness in the United States. Like many of the other microorganisms, it's naturally present in the soil and the environment. The Clostridium perfringens bacteria produces spores that are somewhat resistant to heat, such as cooking, roasting, and drying. The spores rapidly grow when improperly cooked foods are not kept hot enough or not cooled quickly enough for storing. So that temperature range where the Clostridium perfringens bacteria can produce those spores really quickly is between 41 and 135 degrees Fahrenheit. And that's called the temperature danger zone. So foods commonly associated with this illness are, large roasts or large whole cooked birds, large batches of gravies and stews and casserole style dishes. Those are all very dense foods that, could maybe have not been cooked thoroughly enough or take a long time to cool. So cooking foods to the proper minimum internal temperature is important in destroying or killing the bacteria so it cannot produce spores. Rick is going to share with you a temperature chart, so feel free to download that and save for future use. And keeping foods out of the temperature danger zone is key to preventing the spores from producing the toxin that causes illness. So simple way, keep hot foods hot, cold foods cold. So this means holding your hot foods at 135 degrees Fahrenheit or above, and cold foods at 41 degrees Fahrenheit or below. Cool any prepared foods as quickly as possible to 41 degrees Fahrenheit or below. So you can do this by cutting those large pieces of meat into smaller pieces, dividing large batches of foods into smaller containers. You can add ice or put that container into an ice water bath and stir. That'll help transfer the heat out to the sides of the dishes where it's cold, where it's up against the cold ice water bath. And then once it's in your refrigerator, leave the container lid cracked open slightly to allow that hot air to escape, and then seal it tightly once it is cooled. And lastly, Staphylococcus aureus, which thankfully is shortened to S. aureus, because I don't know if I could say Staphylococcus aureus multiple times. The S. aureus bacteria is naturally part of the human biome or microflora. And this bacteria can grow in larger than normal numbers when we're sick, or if we have a cut or a wound. And then if unsafe food handling practices are used, then food can become contaminated. So the S. aureus bacteria can easily grow on foods in the temperature danger zone. So between that 41 and 135 degrees Fahrenheit. It's most frequently spread on foods that should be refrigerated, but maybe they're not, or they're being improperly refrigerated. So a good example to use is that's why it's really important to refrigerate cream-filled pastries. Because if there was unsafe food handling and that food became contaminated and it's sitting above 41 degrees, that S. aureus bacteria could grow really, really easily. So the S. aureus bacteria, it can just be destroyed or killed by cooking foods to safe internal temperatures. Killing the bacteria prevents any spores and then toxins. So again, holding foods that need refrigeration at 41 degrees below Fahrenheit 41 degrees Fahrenheit or below is going to help control that bacteria growth, and cooling foods as quickly as possible, as we discussed. There are 4 main ways which foods can become contaminated and cause foodborne illness when eaten. Poor personal hygiene, which includes working while sick, or food handlers not using proper hand washing practices. Both of these actions can spread bacteria to foods and surfaces and other people. And again, all of this can occur during harvesting, processing, packaging, preparing, cooking, selling, or serving foods. Time and temperature abuse, like we talked about. So making sure the foods are held outside of that temperature danger zone. So cold foods cold, hot foods hot, and cooking foods thoroughly. Using contaminated foods or ingredients can also cause foodborne illness. So making sure you're only purchasing from reputable or approved sources, and storing your food safely. And then cross-contamination. So that spread of bacteria from contaminated food or surface to another food. So making sure we're using separate cutting boards and utensils in between tasks, and cleaning and sanitizing things correctly. Okay.
Thanks everyone for attending. We'd love to get your feedback on the webinar today. So we'll do this first, and then we'll go back to answering questions for those of you that can stay a couple minutes extra. This is an evaluation survey that Rick put in the chat. It should just take a few minutes, and your responses are anonymous, and it will be used to guide future programs. You can also scan the QR code on the screen with your phone, or click the link that Rick put in the chat. And yeah, we really appreciate it. So our next, Rick also put in the chat, and it's on the screen, a link to our website that has our upcoming webinars. So next month will be about the factors that influence pathogen growth and how you can control these to produce and serve safe food. As always, registration is free, but it is required. And unfortunately, you do have to register for each of these monthly webinars separately. So there's one every month, or one topic every month, but starting in April, all of the sessions will be offered twice a month. So they're at different times. So if you can't make one day work, maybe you can make the next work. And again, that link to signing up for those future webinars is in the chat. And I think we will move on to some questions. So Suzanne asked, could you email the links to the handouts? Yes. So after this workshop, we will be able to email maybe the slides, or at least the topics that we covered. And then there were several questions in the chat earlier in the session. So I just want to thank everyone again for coming. And if you can stay for another few minutes, that's great. We'll answer those. And if not, thank you again, and hope to see you next session. All right. So Kathy asked a question about Clostridium. Would that be a major risk in black garlic as well?
So Clostridium botulinum in black garlic, so Clostridium botulinum is that there's the bacteria that produces the spores, and it's when those spores are able to produce the toxin in an environment with little or no oxygen. So I can't answer that completely because I'll need to do a little bit of research. Because I want to make sure I understand the complete process of making the black garlic. If during that process, if there is oxygen present, that's going to limit or prevent any spore production. And it would be, how is it being packaged that could potentially lead to the toxin being produced. So I'll do some research on that. And again, we'll include answers to the questions in the follow-up email.
Do you want me to keep reading the questions, Amy, or do you want me to pause and then we'll email the answers?
You can read me the next one.
Okay. So someone asked, are foodborne illnesses associated with any particular foods like chicken or melons? I know you kind of went through some of this, so maybe some of these have been answered, but
Yeah.
how long can norovirus generally survive on surfaces? I think you mentioned a significant amount of time, but maybe not an actual amount.
Yeah, and I can pull up that. I don't want to say the wrong number, but again, we can put that in the follow-up email about how long norovirus can survive on a surface.
This is one that comes up a lot with growers. What is the best way to wash produce? I've been told not to use the produce washes that are sold in the stores.
So for at-home use, so kind of two different worlds. So our growers, producers, the produce wash that they have it's a sanitizer. That's food safe, food grade. And so that is different than a produce wash that you might see at like a grocery store, or a Target. Two totally different kind of chemicals. So there is good research supporting the use of that food wash for our growers, producers for certain specific foods. And if somebody has more questions about that, we can make sure to connect with resources from Annalisa, our on-farm food safety specialist. But at home, if you're washing produce, there is limited evidence to show the effectiveness of those kind of produce washes that you would buy at a store. We do have a good link on our website about washing produce, so we'll make sure to include that in the follow-up email, and it answers some of that as well. Like, can I use vinegar or things like that? And then the third option is, if you're in a food processing, food service operation, there are also produce washes that are good and proven use, effectiveness for in that type of operation as well. So long-winded answer, sorry.
Let's see. How does freezing food affect these pathogens?
Oh, that's an excellent lead into February. So freezing does not kill pathogens or viruses. It stops them from growing or multiplying. But once a food is thawed, that pathogen has the opportunity to be active again. So if a food was accidentally contaminated, frozen, and now thawed, if it was improperly thawed, so it was held in that temperature danger zone of between 41 and 135, that bacteria could grow really rapidly. If the food is thawed appropriately, that's really going to minimize any risk of increased bacteria activity or growth because you're keeping it below that 41 degrees Fahrenheit. So join us in February for more info on that.
There was another question about norovirus, if it could live on non-food surfaces, which we already answered yes. Let's see. Mary asks, when a food is impacted with a microorganism, is there an odor that can identify the infection?
No, so I know that smell or taste test that will those are not good indicators to know if a food is safe or not. You can't smell the contamination and you can't taste the contamination. What you can smell or taste is, if a food is spoiled or moldy. So that only covers, a small amount of contamination. If there is that mold or some kind of fungus present, but you're not going to be able to smell salmonella.
Okay, I think that just about does it. And I will look back at these questions. So if we did miss any, I apologize. We will get to them in a follow-up. Yeah, I just wanted to thank everyone again, and we hope to continue to see you at these monthly webinars. And if you have any questions, we'll stay on for a few more minutes. You can stick around, write them in the chat. Thanks again, Rick, for your support. Amy, do you have anything else to add?
No, thank you.
Okay.
The one question that I did see was about sanitizing cooking boards,
Oh,
and that was towards the end.
good.
But,
Yeah, so March topic, we'll definitely cover that in detail. But yeah, sanitizing cutting boards is important. There's different sanitizing solutions, like I mentioned. You want to make sure your cutting boards, especially ones that you're using for produce and meat, are not wood or porous. Because if there's bacteria, those can get down into those pores and stay there and grow and multiply because they're tinier than water molecules and the sanitizer molecules. So make sure it's like a hard, rigid surface or material for your cutting boards, and replace them if they become, extremely scratched or damaged.
and does the dishwasher work for sanitizing them?
Yeah, so that would fall into like a hot water sanitizing process. Excellent.
I'll stop the recording.
Great.